Hello everyone. I hope I'm audible and visible. Hello everyone. A very good evening. We will start the session within 5 to 10 minutes so that everyone can able to join the session.
Good evening, ma'am.
Good evening, good evening. Actually, we
Puja
have
madam.
preponed our session. Good evening. Okay, so let's start the session. Hello everyone, my name is Pooja Verma. I am PMR Research Scholar from IIT Kharagpur and instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering, IIT Kharagpur. This is a week 12 live and interactive session on computer vision. So I hope all of you have gone this week video lectures. It's already released in the last week. So here we will solve some problems which will be very similar to your assignment problem so that you can able to solve these problems. So for this week, the course content is deep neural network architecture and its applications. So let's some let's solve some problems which will be very similar to your assignment questions. So our question number one is Google Net has 9 inception modules stacked linearly. As it becomes very deep network, it is subject to the vanishing gradient problem. What strategy has been taken to get rid of vanishing gradient problem in GoogleNet? Option A. Essentially, softmax is applied to the outputs of two of the inception module and computed an auxiliary loss over the same labels. The total loss function is the weighted sum of the auxiliary loss and the real loss. Option B is skip connections are used to every alternative inception module to get rid of vanishing gradient problem. Or option C is data augmentation is used by transforming original image set and stack all the transformed image and use the stack as single data. Thus, they remove vanishing gradient problem. Option B is none of the above. So, which option can be a correct one? Please try to answer for this question. Any guesses? Anything? Then we will solve the detailed. We will see the detailed explanation later. Okay, so let's see the detailed explanation for this question. So the detailed explanation like this GoogleNet, it is also known as the inception event. Inception is is also an one type of network, and it is released in 2014. And Inception Net also have three versions: V1, V2, and V3. Inception V1 is called as a Google Net. Okay, and it is a 22-layer deep convolution neural network architecture with nine inception modules that are stacked linearly. As networks become deeper, they suffer from the vanishing gradient problem, where gradients from the loss function diminishing as they are back propagated through many layers. This makes earlier layers harder to train. So, to address this problem, the authors of the GoogleNet introduced auxiliary classifiers. This one, auxiliary classifiers. So, first, auxiliary softmax output that has two intermediate inception modules around the middle layer and that are connected to their own softmax classifiers. And in the auxiliary softmax output, each of these produces an auxiliary output, a probability distribution over classes. And these auxiliary outputs are trained using the same ground truth labels. And the another thing that has introduced that is the auxiliary losses. So a entropy loss is computed for each auxiliary output, and the total loss during the training is calculated as a main loss that is in the final layer plus weighted sum of the auxiliary losses. So the auxiliary loss weight is gradually reduced during the training in that case. So what is the purpose to add the auxiliary classifiers? That is one is auxiliary softmax output and another one is the auxiliary losses. So it helps a gradient flow more easily to earlier layers and act as a regularization to reduce the overfitting problem. So it improves convergence speed. So our options are the essentially softmax is applied to the outputs of the two inception modules and computed an auxiliary loss over the same level. So the total loss is weighted sum of the auxiliary loss plus real loss. So that we have seen when we are adding the auxiliary classifier. So this one is correct. Option B is skip connection related to the skip connection. So the skip connection module is introduced in the ResoNet, not in the GoogleNet. And ResoNet is introduced in 2015 after GoogleNet. Okay. And data augmentation techniques that improves generalization that have been applied to all the neural networks before giving the input, but it does not address the vanishing gradient problem. None of the it is incorrect because option A is the real solution that have been used in the GoogleNet. Okay, so option A is the correct answer for this question. Okay, okay. I hope all of you have understand this question or have seen these questions. So moving to the next question. Our next question is compute a convolution layer C which has input channel 3, output channel 32 and kernel size 3 cross 3 and a pooling layer P which has kernel size 2 cross 2. Compute the number of parameters for each of these layers. So now we have to compute the number of parameters for convolution layer as well as pooling layer. Okay, so any idea how to solve this question? Okay, so to compute the number of layers or number of parameters in the convolution layer as well as in the pooling layer, we will see here. So the number of parameters in convolution layer is calculated by this one is like parameter activity is equal to kernel height after here kernel width kernel width and multiplied by input channel plus 1. Okay, and then after that multiplied by output channel. Okay, so here what plus 1 indicates? So plus 1 indicates it accounts for the bias term for each output channel. The plus 1 here accounts for the bias term for each output channel. Okay, so now can you compute the number of parameters in convolution layer? In convolution layer, let's say it is C. Here you can write number of parameters in convolution layer. So already for the convolution layer, the input channel is 3, output channel is 32, kernel size is 3 cross 3. That means kernel, it is a kernel, one is related to kernel height and another one is a kernel width. Okay, so just put all those things. The kernel height is 3 and kernel width is also 3. Input channel is also 3. It is given plus 1. Okay, and all those things is again multiplied by the output channel. Okay, our output channel is given as a 32. So if you just, it is a 27 plus 1 multiplied by 32 and it is a 28 good or multiplied by 32. So now can you at least calculate it or multiply it? 28 multiplied by 32, what value you will get? Can you answer for this at least? So if you multiply these two numbers, you will get 896. Okay, so the number of parameters in convolution layer is 896. Now number of parameters in the pooling layer we need to calculate. So what is a pooling layer? So a pooling layer, like a max pooling or average pooling, we will calculate, is a fixed function with no trainable weight or biases. It simply performs an operation like taking a maximum value or taking an average value. If you perform the average pooling, so if you will take an average value. If you are performing the max pooling, so you will take the maximum value over a given region or a given mask. Okay, so the parameters in the pooling layer p is equal to 0 because there is no trainable weights and biases. It is just simply a mask, or you can say that kernel size 2 cross 2. From there, we have to take a maximum value or average value simply in the 2 cross 2 mask or kernel size. So the parameters in the pooling layer P will be 0 only. Okay, I can write it here. A pooling layer and also writing example max pooling or average pooling is a fixed function with no weights or biases, trainable weights or biases. So it simply perform an operation over a region or kernel size. Kernel size. Okay. So the parameters in pooling layer, let's say P is equal to 0 because there are no weights or biases. So there is no calculation the number of parameters or something in the pooling layer. So that will give us only 0. So answer is C. You have got 896 and P is 0. So if you just see that option B is the correct answer for this question. Okay. So have you understand this question? So I hope all of you have understand this question. And here also I have added the detailed solution so you can see it also later. Now moving to our next question. Our next question is consider a convolution layer C with kernel size K is equal to 3 cross 3. Padding size here it is given as a P 1 cross 1 and stride S is 2 cross 2. Acted on an input map 47 multiplied by 47. What is the dimension of the output feature map? So what will be the dimension of the output feature map? How we can calculate the dimension of the output feature map? Anyone? Okay, so the formula for calculating the output dimension of the convolution layer is output dimension of convolution layer is calculated by calculated by, let's say output dimension is represented by O, and here this function I minus k plus 2p divided by s and plus 1, where I is the input size and k is kernel size, p is the padding, and s is stride. Okay, so here already I is given as a input size our 47, right? Our kernel size is given as a 3 cross 3, so 3. Padding is also given, that is a 1 cross 1, so you can take 1, and stride is also given 2 cross 2, so it is a 2. Okay, so just you need to put all these values in this formula and calculate. So this I, that is 47, minus 3 plus 2 into P, that is 1, divided by S, that is S, right, 2 plus 1. Okay, so 47 minus 3 is 44 plus 2 divided by 2 plus 1, or you can say that 46 divided by 2 plus 1, or directly you can write 23 plus 1, that is equal to 23. So here you will get output dimension is 24, and 24, that means 24 cross 24. Okay, the output dimension is 24 cross 24. So if you see on the options, you will get option C is the correct answer for this question. Okay. Okay, so have you understand this question also? Okay, so I hope all of you have understand this question. So here detailed solution again I have added here. So you can see later also. Now moving to our next question. Our next question is, consider a single layer perceptron with learning rate neta is equal to 0.1, input vector x is 1, 2, target output given as t is equal to 1, and current weight vector, that is a w, given 0.2 and 0.5. The perceptron uses a simple linear activation, that y is equal to w x. What will be the updated weight vector after one gradient descent? So what will be our updated weight vector after one step or after one gradient descent? So anyone, how to calculate this question? So weight update of gradient descent is calculated by weight update of gradient descent calculated by, this is, let's say, it's a new weights w new, the old weight that is already given here, plus neta t minus y into x. Okay, and here output y is not given, so first we need to calculate y, that is, we can say that prediction y is calculated by w into x. Already here it is a given, the perceptron is simple linear activation y, so y is w into x, so that is already given. Weight vector 0.2, 0.5, and input vector is 1, 2. So for both we have to calculate, so we have to multiply 1 into 0.5 plus 2 into 0.5, 0.2 and 0.5, sorry, 0.2 into 1 plus 0.5 into 2, right? So here you will get 0.2 plus 1. So overall we will get y 1.2. Okay, now we have calculated the y and other values already given here. Here it is our old weight vector. So this is 0.2, and 0.5 plus meter is given as 0.1. T is 1. 1 minus 1.2 y we had calculated here into x. So x vector is given 1, 2 here. Okay. So here we need to multiply. So 0.2, 0.5. You can calculate one by one also. First take 0.2 and 1. Then next one I am taking here parallelly in the vector form. So you can do this way also. Okay. So here 0.1. Here you will get minus 0.2 and this weight vector 1, 2. So 0.2, 0.5 plus here you will get minus 0.02. Okay, and the weight vector 1, 2. If you just further multiply this in here again, so here you can directly take the minus sign out, and here you will get 0.02, and here you will get 0.04, right? Now, if you just subtract these values, this one from this one, this one from this one, so you will get 0.18 and 0.46 as a weight vector. Now, if you see from the options, there is no option is matching, but you have to choose the nearest one. So the nearest one, it is approximately nearest, so 0.21 and 0.52. Okay, so nearest one, for that you have to choose so option B, in that case the correct answer for this question. Okay, so have you got this question? Shall we move to our next question? Okay, so let's move to our next question. So our next question is, a loss function is designed which has a component of regularization loss that gets multiplied with the hyperparameter lambda and added with the other components. Consider a 3 cross 3 filter for a single channel input of a CNN. What would be the contribution of a regularization component towards the loss function if a square of the Frobenius norm of the filter mask is used as a measure? Assume that the value of lambda is 1. So here a 3 cross 3 filter, a single channel input CNN is given as this one. Now we have to calculate the Frobenius norm. Okay, here this is Frobenius norm. So they are asking what would be the contribution of the regularization component towards the loss function if the square of the Frobenius, here it is if the square of the Frobenius norm of the filter mask is used as a measure. So already filter mask is given. This one, let's say it is our W. So the regularization component is given by a lambda. That measure is a square of the Frobenius norm of the linear mask. That is Frobenius mask is denoted by this one, mod of W f square. Okay. So the Frobenius norm squared is the sum of the squared of the all elements in the matrix. Okay, so it is calculated as a I J W I the square. It is calculated by this one. Okay, so just take the squared value of all the elements in this mask. So if you just calculate, so you will get 1 square, right? 1 square plus 2 square plus 1 square. Then again in the next, this one, 2 square plus minus of 4 square plus 2 square. Now next one is 1 square plus 2 square plus 1 square. Now take a square and add all these values. So 1 plus 4 plus 1 plus 4 plus 16 you will get, plus 4 plus 1 plus 4 plus 1. Now add all these values, so you will get 36, right? The contribution to the loss is calculated by the contribution to the loss is, that is lambda by the Frobenius norm, that is W F square. So lambda, it is already given here. Lambda is 1. Lambda is equal to 1. So just 1 multiplied by 36. So overall you will get 36. Okay. So if you see, option B is the correct for this question. The Frobenius norm is 36. Okay. So are you getting these questions? Anyone? Any doubt? Anything? Okay. So I hope all of you have are getting these questions. Now moving to our next question. Already detailed solution I have added here. So our next question is, the Dice coefficient is a common metric used to evaluate image segmentation model. If a segmentation model predicts 100 pixels for an object like predicted area P, and the ground truth of the object is 120 pixels, ground truth area G, let's say, with an overlap intersection of the 80 pixels between the prediction and the ground truth, what is the Dice coefficient? So here it is given as the Dice coefficient is a common metric used to evaluate the image segmentation model, and here predicted data, ground truth data, and intersection, that means overlap pixels are given. So how to calculate the Dice coefficient? Anyone? Anyone know what is the formula for Dice coefficient, or any idea? Please try to give answer for this at least. So no idea about what is a Dice coefficient. And okay, so I will let you know Dice coefficient is also known as a F1 measure or F1 score. It is also known as a F1 score or F1 measure. F measure you must have been listened or studied somewhere, like recall, precision, accuracy, F1 score. We are measuring all the time whenever we are performing the deep learning or machine learning task. Okay, so I will let you know what is the formula for the Dice coefficient. So the Dice coefficient is calculated by that is equal to 2 cross that is intersection area, or you can say overlap area, divided by predicted area plus ground truth area, or you can say ground truth data area. So this is the formula, and it is also known as a F1 measure or F1 score. You can say that F1 score. It is also known as a F1 score. So already all these values are given. So our intersection area is 80 pixels. So 2 cross 80. Predicted area is given 100 pixels, and our ground truth is given as a 120. Right? You will get 160 divided by, if you add these two values, you will get 220. Right? So if you further just divide it, you will get 0.72727. This. So 0.727, you can say that our Dias coefficient is. So if you just match with the answer, you will get option D is the correct answer for this question. Okay. Okay. So I hope all of you have understand this question. Now moving to our next question. Our next question is, which of the following activation function is characterized by gradient that are either 0 or 1, which helps in preventing a vanishing gradient problem in the positive region. So option A is sigmoid, option B is tan hyperbolic, or option C is ReLU, or option D is leaky ReLU. So which option is correct one? Would you like to answer this question? Which of the following activation function is characterized by gradient that are either 0 or 1, which helps to preventing the vanishing gradient problem in the positive region? Okay, option A. Okay, let we will see this option. So I will wait just then we will discuss on the solutions. Okay, so you can answer also for this question parallelly. Which of the following activation function is characterized by gradients that are either 0 or 1, and that helps also preventing the vanishing gradient problem in the positive region. Okay, so let's see the explanation of this question. So explanation is the ReLU function, that is also known as a rectified linear unit. So the rectified linear unit is defined by this function f of x maximum 0, x, and for x greater than 0, so the derivative, that is df divided by dx, is 1, and this constant non-zero gradient one ensures that the gradient signal does not vanish as it propagates backward through many layers. Effectively mitigates the vanishing gradient problem in the positive input space. And for if x is less than 0, then derivative is df is 0, and that leads to a dying ReLU problem. Okay, and sigmoid and tan hyperbolic, both functions are suffer from the vanishing gradient problem because their derivatives approach 0, and when the input x is very large in in the saturation region. And in the leaky ReLU, this is the extension of the basically ReLU function. For x less than 0, the gradient is a small positive constant that is 0.001, not 0, that prevents the dying value problem. Okay. And for x greater than 1, the gradient is still 1 for that. So correct answer is C, not A. Okay. That is ReLU function. ReLU function helps in preventing the vanishing gradient problem in the positive region. Okay. Okay. So moving to our next question. Now, next question is learning a large network as easy as stacking more layers? What is the main problem in answering this question? Option A is vanishing or exploding gradient. Option B is overfitting. Option C is possibility of data augmentation. Or option D, none of above. So, to try to answer for this question, is the learning a large network as easy as stacking more layers? And what will be the problem for answering this question? Any one of you try to answer this question? Okay, so let's see the solution for this question. The explanation is given as neural network gets deeper. A major challenge in training them using the back propagation is the unstable nature of the gradient. Okay, the one is vanishing gradient. So the gradient that becomes very small as they propagated backward to many layers. That causes the weights in the initial layer to update minimally or not at all. And the second problem is exploding gradients. The gradients become extremely large and leading to the unstable learning and overflow errors. So the development of the resonance, let's say, with a skip connection was direct answer to this problem of the vanishing gradient, which showed that simply stacking more layers did not automatically lead to a better performance. Okay, so resonate basically perform with the skip connections. So answer A is yes, correct one. The vanishing and exploding gradients. That means when the gradients become very small or when the gradients become extremely large. So this is the problem in the neural network when it gets deeper. So is this is the answer. Option A is the correct answer for this question. So learning a large network as easy as stacking more layers. So the main problem is stacking more layers, that is a vanishing or exploding gradient. Okay. Okay. So moving to our next question. Now next question is what is the use of flop? Option A is it is used to measure computer performance by measuring total number of floating point operations. Option B, it is used for measuring total memory occupied by the deep network. Option C, it is used to measure computer performance by measuring total number of parameters in deep networks. Or option D, none of them. So what is use of flops? Anyone? Please try to answer for this question at least. Okay, option C, it is used to measure computer performance. by measuring total number of parameters in the deep network. Okay. Okay, so let's see the solution. So basically, FLOP stand for floating point operations per second. That means in 1 second, how many floating point operation has been done in the neural network. So basically, it is a unit to measure the speed or performance of a computer or computational process that specifically in the field of like scientific computing and deep neural networks or deep learning by counting total number of floating point arithmetic operations like addition, subtraction, multiplication, or division, it can execute per second. So option A is the correctly defined that flops is a measure of computer performance by measuring total number of floating point operations at usually per second, but the total count is often used as a proxy for complexity. And option B measures memory usage, that is not correct. Measures model size complexity, not performance. So option A is the correct answer that it used to measure computer performance by measuring total number of floating point operation, not a number of parameters. So number of parameters that we are calculating that is not related to a flop. Okay. So option E is the correct answer for this question. So total number of parameters actually used for the memory. If the total number of parameters are larger or greater, then it takes more and more memory. Okay, it is not related to the problem, that is floating point operations. So I hope you have got this question. Now moving to our next question. Our next question is basically a reasoning type question. So I'm just stream this question. You can answer at least. You can try to answer this question at least. So question is Rajesh working in an Indian NCO who needs to develop a system for identifying any animal automatically given an image. Okay, he has trained. Just a minute. He has trained one network using a dataset of 100 million containing animals found in his country. He visited Boston, USA for attending a meeting where he met a friend, Tracy, who is struggling with training a network with a data set of size 110K which contains animals found in her city. She is also working in an NGO in Boston. Rajesh said to Tracy, "You can take my trained network. It will definitely help you." Why does Rajesh claim that his network will help Tracy? Option A is Rajesh knows that Tracy's data distribution is similar to training data distribution, hence his network can predict her data. Or option B, Rajesh knows that through data distribution of traces collection is different and type of classes may be different, but still it is animal data. Hence, he is sure that while Tracy fine tune his network with her dataset, it will learn better. Option C, Rajesh is trying to make a connection for his NGO. Or option D, proper reason is not enlisted. So can you try for this question? This is a reasoning based question. I think you can try for this question at least. I will wait for just 2 minutes. Okay, try to answer this question. Just read this question and try to answer this question. Okay, A and B seems to be right. Okay, we will see. Please, everyone, try for this question. This is a reasoning based question, and this is a previous year assignment problem. This is game. Okay, so this type of question you can expect also in your exam. This is one of the previous year assignment problem. Okay, so let's see the solution. So here it is given Rajesh has a network that trained on the large dataset that is 100 million of animals from India. And Tracy is struggling to train a network with a small dataset that is a 10K data of animals, but that is from Boston. So the principle at play here is the transfer learning. Okay, so here the principle or mechanism that have been used to train the on the new dataset that is a transfer learning. Okay, so a network that has trained on the huge or general dataset, if the specific object or classes are different, will have learned robust general purpose features that is edges, texture, shapes in its lower layer. Already it has learned better because already trained on the very large data set. Okay, so already if you are working on that deep learning or any related project, so already you know that actually most of the models are trained on the COCO dataset or ImageNet dataset, right? Yeah, so you can ask if you have any doubt.
Yes, ma'am. See, option A also seems to be correct, ma'am. Why A is wrong? B is exactly understood. But
Okay,
why
okay,
A is wrong?
we will discuss on that.
Yeah.
Let me explain first. Okay.
Because countries may be different, but the data is similar data, and he has a large set of data, right? 100 millions, and Racy, I think Racy has only 10K data. I
Yes,
think that is
she
sufficient
has.
for her to sort out, right?
But the animals may be different now. The same types of animals in India, animals are different, and in US, the animals may be a different. Okay, so actually, Rajesh has given his network for using as a transfer learning. So that's what I am explaining here. So already the network has been trained on a huge or large data set, right? So already that network has been a very general purpose features that is edges, texture, and shapes that has been already trained on the lower layers. So that features that can be used by a tracee. So it will not take that much of time or that much of complexity to train on the small data set. So basically what we are doing, we are already doing the same things. We are taking any data like VGG or you can take resonate any data or RCNN, CNN, you can take any data. So when you are training, so that all the networks already trained on the COCO dataset or image net dataset, right? And after that, you are training your dataset on that. So already that network already trained on the different types of images and different situations, conditions. So already that know the basic features, right? Like different edges, textures, and shapes. So when you are again training on that new data set, basically you are using the transfer learning mechanism. Okay, so that will learn better. If you start from the scratch, so that will take as well as time and that will not train properly. Okay, so here we will discuss in detail why A is not correct and the B is incorrect, more suitable for this option. So here the Tracy can take Raj's pre-trained network and use it as a feature extractor or fine-tuned it on her small 10K Boston animal dataset. So this process is much more effective than training new network from the scratch on a small dataset, and which would likely to lead to a overfitting problem. Okay, so here already given option E is highly unlikely because the data distribution from the two different countries or region are rarely exactly similar. Rarely. Okay, and option B precisely describes the concept of transfer learning or fine tuning. The pre-trained network provides the good starting point, and Tracy can fine tune it with her dataset to adopt the learning feature to her specific data. So here is option A was Rajesh know that Tracy data distribution is similar to his training data distribution. Hence, his network can predict her dataset, but it is not a correct. His network cannot be a predict her data because the some features or some animals are the different from US and India, right? So it cannot be a properly correct. So option B is Rajesh knows that through data distribution of the traces collection is different and types of classes may be different, but still it is a animal data basically. Already 100 million data he has, and he again train on the 10K data set with different animals. So his model may be a more robust in prediction. Okay. Hence, he is sure that while Tracy fine-tune his network with her dataset, it will learn more better. Okay, so option B is actually most likely or most recent correct. Okay, it is not sure that in the option his network can predict her dataset. It is not possible. Maybe some animals are different, which is not included in 100 million dataset. It is possible because the both regions or countries animals may be some animals, not all, but some animals can be a different one that he has collected or she has collected. Okay, so that's why A cannot be a properly correct answer for this question. Okay, so have you understand why A is not the correct option?
Okay, ma'am. Thank you.
Okay, so moving to our next question. Now, next question is assume you have been given an image which depicts that a lady is standing beside SUV. Someone asks you to identify the car within the image. What task are you doing? Option A object recognition, option B object localization, option C object segmentation, or option D none of the above. So, can you answer for this question at least? Assume you have given an image which depicts that a lady is standing beside a SUV. Okay. And someone asks you to identify the car within image. So what task are you doing? Object recognition, localization, or segmentation, basically, or
Object
none.
A, ma'am. Object A. Sorry, object
Object
recognition.
object recognition you are doing. Okay, you can see in a simple way. Okay, so in an image there is a lady, car, and other things maybe, right? So you have asked to identify the car within an image. So you are recognized in
We are
whole
asked
image.
to identify the car or type of the car, ma'am.
You are asked to identify the car within image.
Then it is segmentation, I think.
No, not a segmentation. Okay, so okay, let's see the detailed solution here first.
I'm sorry, madam.
Okay, no issues. At least you try to answer for this question. That is sufficient. Okay, so this type of problem may be you will get. So this is a way basically a very conceptual and very, I mean, this type of question. You have to just think about each of these options. Okay. So here, recognition basically also known as the image classification. Okay. In any image you are given, you have just recognized this is a lady, this is a car, and this other thing. Okay. So in the object recognition, basically the task is focus on identifying what is present in an image. Okay. Not their location. It is not describing where the image it is. Okay. So it just in the image, there are multiple, I mean, objects there. So the output is a label or category of for the entire image, not a single object. So that indicates the dominant object or scene. For example, given an image, an object recognition model might output cat, dog, or landscape. Okay, it will give three because in image there is a person, a lady, a car, and there is a road also, and some other things also. So it will give all the answer, but where it is, it will not tell you. Okay, so it does not provide information about the location or precise boundary of the object within the image. Where object localization, what object localization is, this task goes beyond more identification by also determining where the specific object is located within an image. So the output typically includes a bounding box. Already you have seen a rectangular coordinate that encloses the object along with its class label. Okay. So while it provides a location information, it does not offer fine-grained details about the object's state. So object detection is an extension of the object localization that handles multiple objects within an image. Okay. So in the object localization, just we have given that an image, a lady and a car is given. Okay. So it will tell only we have asked for car. So that will localize that only this is a car. And while object detection, that will tell all those things. Okay, there is a car, there is a lady. All this in the bounding box format, it will give. Okay, this is a lady, this is a car. Okay, in object detection it is. And while object segmentation, so this is a more detailed of the three tasks, aiming to identify what an object is and it precisely delineates its shape and at a pixel level. Okay, so the output is a pixel-wise mask for each object, effectively outline its extracted boundaries. So this allow a much more granular understanding of the object form compared to a single bounding box. So there are two main types of object segmentation, that is the semantic segmentation and instant segmentation also. So in the semantic segmentation, that assigns a label, car label, class label, you can say that, to every pixel in an image, treating all instances of the same object class as a single entity. That is all car pixel are the same color. That and in the instance segmentation that identifies and segments each individual instances of an object within image, even they if they belongs to a same class. Okay, that distinguish between the two separate car or object. So object localization is the best answer. So here I have taken one example like this. One image is given, input image. Okay, so if the image classification that tells that is dog, both are dogs here. But in the object detection, it will give a bounding box. Okay, this is a dog. And in the image instance segmentation, it will segment the pixel wise that their shape and everything it will segment. Okay, this is the difference of three of them. So they have asked that someone asked you to identify car within image. So we have to just identify the car. So if you take the object recognition, so that will tell like this. There is a car, but where it is, that we don't know. Okay, so object localization is the best answer for this question. Okay, that is, so your task will be the object localization, not a recognition or object segmentation. Yes, yes.
Madam,
Yes.
segmentation is also doing the same task, right, ma'am? It is clearly giving the information.
Pixel wise information that will give, but that is not telling that this is a car or this is a dog. Just it is segmenting that part.
After localize, I mean, after identifying the image only, it will do the segmentation, right?
Okay. Um, yeah, after localization, you can do a segmentation. Actually, both are different.
Then
In
that
the
also seems to be
segmentation,
right.
that will segment that part only. Okay, this is a dog or this is a SUV. Okay, this is a car. That will segment only that part.
Because in the examples you have given,
Mhm.
segmentation is also identifying the dogs.
Yeah, that also you can say that recognition is also identifying it. In the whole image, it is giving the output. This is a car, but where it is, it that don't know. But they are asking simply ask you to identify the car within the image. So you don't need to go with the segmentation. You have to just localize the car. Where it is car? Where is this car? So more appropriately. Otherwise, the three of the tasks are applicable on the image. Okay, so actually this is a reasoning based question. So you just need to think what is will be the best answer for this question, this type of question. So have you understand what I want to say here?
Understood, madam, but
Yeah,
not
this
fully,
is a
but I
little bit. I mean, because you're thinking in the same way. So if you think like this, what will be the best fit answer? Think about like this. What will be the best answer that can match you? This is actually reasoning based question mostly.
okay, ma'am. Thank you.
So that they are ask कि someone asks you to identify the car within an image only. Okay, that segmentation can be applicable one. But because we don't go that much of complexity, if object localization is telling you, कि, okay, this is a car in this location, that is sufficient for you. Okay, for the answer. Okay, I think you are little bit confused, but just see read the question and just think about this. Which will be the best answer for this question? Your answer can be a correct. Yeah, object segmentation we can apply object segmentation as well, but this is not exactly correct, precisely correct. You can say that if we are able to find out the car in the less robust method or technique, so why we are going to a very
Madam, is
hard.
there a chance for both answers to be correct?
See, if they are asking about just I mean, there is a segment. Actually, that question will be a little bit different in that case.
Because in the
Okay.
assignments we have solved, there are multiple
Mm,
answers in
no,
the
no,
MCQ
but
section.
there is only one answer correct. Okay. In that case, that there is a given. There may be a multiple options can be a correct. So, okay, I will try to take in the actually there is a one extra summary session will be there on Wednesday. So I will try to take one question that will resolve your confusion
Thank you.
about
Thank you
this.
so much, ma'am.
Yeah, okay. Okay, so moving to our next question now. So next question is which makes fast RCNN faster than RCNN? Option A, fast RCNN selects lesser number of region proposal from the given image compared to RCNN. Option B, in fast RCNN, region proposal are prepared from the convolution feature map of a given image. Option C, a separate network is used in fast RCNN to predict region proposals instead of using selective search. Option D, none of the above. So which option can be a correct one? Which makes fast RCNN faster than RCNN? Fast RCNN that selects lesser number of region proposals from the given image compared to RCNN, or a fast RCNN region proposals are prepared from the convolution feature map of a given image. Or option C, a separate network is used in fast RCNN to predict the region of proposals instead of using selective search. Which option can be a correct? Try to answer at least for this question. At least make a guess while yes. Okay, so let's see the detailed explanation. The explanation is the original RCNN, that is a region-based convolution neural network, performed a convolutional feature extraction independently for every region proposal. Okay, while in fast RCNN, that introduced a key optimization, that it runs the CNN once over the entire image to generate a single convolutional feature map. Then it projects all the region proposals onto this feature map. And this avoids redundant feature computation from the thousands of overlapping regions, that making it significantly faster than RCNN. Okay. So our option A is generally false because the number of proposals is similar, but how features are computed is different. And option C is describe faster RCNN, which uses the region proposal network instead of selective search. That is not using the selective search in in the fast RCNN. And option B accurately actually describes the main speed of mechanism of fast RCNN over RCNN. So in the fast RCNN, region proposals are prepared from the convolution feature map of a given image. Okay, so option B is the correct answer for this question. That in fast RCNN, region proposals are prepared from the convolution feature map of the given image. Okay, okay, so I hope you have got this question. So now moving to our next question. Now, next question is, a model uses L2 regularization on its weight for a particular set of weights, that is W, from a given layer. The weights are W given as 1, -2, 3, and -4. If the regularization coefficient is lambda, that is equal to 0.5, what is the contribution of the L2 regularization to the total loss? What is the contribution of the L2 regularization to the total loss? So how we can calculate this question? Any idea? And anyone knows that how to calculate L2 regularization loss? You must be having studied about this L2 regularization. Okay, so let's see. So the formula for calculating the L2 regularization term in the term of loss function. So the L2 regularization in the loss function is calculated by the loss function is calculated by, let's say it is a L2 loss that is calculated 1 by 2 lambda summation of all i's, that is weight square. It is calculated. So already wi's are given, that is 1, minus 2, 3 and minus 4. Okay, and lambda is also given. Lambda is equal to 0.5 and w, that is weight vector, is given as 1, minus 2, 3 and minus 4. So just need to simply put in this formula 0.5 and you have to take the summation, squared summation of all these weight vectors. So 1 square plus minus of 2 square plus 3 square plus minus of 4 square. Okay, so 1 by 2 multiplied by 0.5 here, 1 plus 4 plus 9 plus 16. So further, if you add all these values, you will get 30. So if you just multiply 0.5 into 15, so you will get 7.5. Okay, so this is the contribution of the L2 regularization to the total loss. So option C is the correct answer for this question. Okay, so have you understand this question? Okay, so I hope you have understand this question. So now our next question is, if dropout rate is 0.5 and a neuron has output 0.8 during training, what is its expected output during inference? So here we have to assume, here it is already given in the question, assuming inverted dropout scaling. Here we have to assume that there is an inverted dropout scaling. A dropout rate is given and neurons output is given. Now we have to calculate what is the expected output during inference. So how we can calculate? So mostly in this section, in the deep neural network in the last week, there is a mostly tricky and reasoning based questions are there. There is a no longer calculations and other things will be there. So you just need to focus in the question and go through this basic concepts. Okay, in all this, whatever they have studied in this week. Okay, so let's solve this question. So inverted dropout scales during trading neuron, that is dropout rate, that means a probability that is given. Okay, so I'm writing here inverted dropout scales during training neuron. The active probability P is given. So what will be the our scaled output? Scaled output, that is calculated by that the given output during the training, output during training, and the dropout rate. Dropout rate. Okay. The output during training is given as 0.8 and dropout scale is 0.5. So if you just say 1.6, you will get. But here trick is there. They are asking what is its expected output during inference, not training. Okay. So at inference, there is a no dropout. So there is a no scaling will be there. So they are asking for inference. Okay, so at inference, there is a no dropout, and no scaling will be performed in that case. Okay, so the output during inference is same as during training. That will be the zero point 0.8. Okay, so here option A is correct, not C, because the scaled output they have already given confuse to confuse you. Okay, so just read the questions and just think about this. So what they are asking, what is its expected output during inference? Okay, where to confuse you, they have given assuming inverted dropout scaling. So they have given this to confuse you. Okay, so don't confuse. So option A is the correct answer, because at inference there is a no dropout, no scaling can be performed. So the output, whatever the output during training, that will be the same during inference. Okay, okay. So I hope you are getting these questions. So now moving to our next question. So our next question is, a batch has value that is 2468. Batch norm that is normalizes with mean mu is equal to 5 and variance is given as 5. What is the normalized value of 8? In this batch that is given, what is the normalized value for 8? Okay, so the batch that is normalized with mean mu is equal to 5 and variance is equal to 5. Variance is also 5. So here already they have hinted you mean is given, variance is given. So what function they are using to normalize a batch? That is a batch norm. So they have hinted you. So you can just do this. So the batch norm normalizes by, that is this is the normalization function. So x minus mu divided by sigma square plus, here stands for error. Okay, so there is a no error is given, so that is equal to 0. Okay, so they have asked what is the value for 8. So that means x is equal to 8. For this one only they have asked 8, mu is given 8 minus 5, and already sigma square is also given. So root of 5. So here you will get 3 divided by root of 5. So now what is the value for root 5? Can you calculate? What will be the value for root 5?
Around
Okay,
2.3, ma'am.
okay, yeah, 2.236 exact value this. So if you further divide it, you will get 1.34. Okay, so if you just match with the answer, so option A is the correct answer for this question. Okay, okay, so I hope you have understand this question. So now moving to our next question. So our next question is, consider a fully connected ANN with input layer is 4 neurons, in the hidden layer 5 neurons, and output layer has a 3 neurons. How many trainable weights are there in total? So in the note they have given all layers include bias neurons. Okay, that means input layer and hidden layer must be include the bias neurons. So there are 4 inputs, 5 in the hidden layer, and output layer is 3. So as they have not described here how many bias, and for each neuron there is a one bias, or for the input one bias is there, for output. Okay, in the general case only one bias for the input and one bias for the output. Okay, so here let's say input to hidden layer. Okay, so for that we have to calculate what will be the size for the input to hidden layer. How many parameters or how many calculations will be there. So here it is input to hidden. So here 4 inputs are given, and they have also indicated that all layers include bias neurons. That means one bias will be there with one input. 4 inputs and one bias. Okay, so that is the input will be the total 5, and whenever we are calculating, that is 5 cross 5, right? That is kernel size. So that will be the total inputs will be 25. Similarly, hidden layer to output layer, how many neurons or how many parameters or how many calculations for that trainable weights will be there. Hidden layer to output layer. The total hidden layer is 5, right? 5 hidden layer plus 1 bias, because they have said that. Okay, and so here this is the next hidden layer, and in this where it is going hidden to output. So how many output layers? So in the output there is a 3 neurons. So total calculation will be there. Similarly for this one also. Sorry, here 5, that is from there. Input to hidden we are going. So in the hidden layer 5 neurons will be there. So total input into 5 hidden layer. Similarly for this one also. So 6 total is 6 multiplied by 3. So total 18 trainable weights from the hidden to output. Okay, so now we need to calculate the total neurons. So how many total neurons will be for the trainable weights? So in the input to hidden there is a 25, and in hidden to output there is a 18. So if you just add this, so you will get 43, right? Yeah. So total trainable weights are 43 in the fully connected ANN layer. ANN. So option C is the correct answer for this question. So have you understand this question? How to find out the trainable weights? How many total trainable weights are will be there? So have you understand this question?
Ma'am, yes, ma'am.
Okay, okay. So now moving to our next question. So next question is a binary classifier ANN uses cross entropy loss, that is represented by L is equal to minus T log, T log Y plus 1 minus T log, or you can say it is a natural log ln 1 minus y. So for target t is equal to 1, output is given at 0.9. Now we need to compute a loss. So already values are given, right? And out, so you can directly put in the formula. Can you calculate for this question at least, and let me know what will be the answer for this question? At least try to compute, calculate this question. Already values are given, just you need to, and formula is also given here. So For binary classifier NN that is uses the cross entropy loss, what will be the value? Can you tell me? Anyone? Are you calculating the value?
Yes, ma'am.
Okay. Okay. So let's calculate. So put in this formula. So t is equal to 1, y is equal to 0.9. It is given already given. So minus in bracket 1 ln that is 0.9.
Option A is correct.
Okay, yeah, right. Option A is correct. So next is 1 minus 1 ln 1 minus 0.9 will be there, right? Minus, so that will be the 0. So whole function will be the 0. So it is left with ln 0.9. So just calculate the value for natural log 0.9. So you will get minus, I think minus 0.105. So over,
10536, ma'am.
yes, 10536. So that is equal to 0.105. So if you just match, so option A is the correct answer for this question. Okay. Okay. So now moving to our next question. Now next question is a CNN layer has 32 filters, each of size 3 cross 3 cross 16, that is height, width and input depth. How many trainable parameters does this layer have, including bias? So can you calculate? So how many total trainable parameters does this layer have? Okay, so a CNN layer has total 32 filters, right? And that 32 filters have each of size 3 cross 16. Okay, so each of size this one. So how many, what will be the total size 3 cross 3 cross 16 if you multiply? So how many total number of parameters will be there? If you multiply these three, you will get 144 parameters here, right? So that this one has a 32 filter and each filter has this size. So for that, so for total 32 filters, for 32 filters, so you will get 32 multiply 144, then you will get total number of parameters. So if you 32 multiplied 144, can you multiply and let me know the answer? What will be the answer? So if you multiply 32 multiplied by 140, so you will get 4608, the total number of trainable
4608,
parameters.
yeah.
Okay. So now you have got, but they have asked including bias. Now we have to add parallelly the 32 biases also, right? For the 32 filters, to add the 32 biases also for each filter. So if you add the 32 biases also, in that case you will get 4640. So they have asked here including bias also. Actually, no option is matching. If they said that excluding bias, in that case option A is the correct, but included here including, so no options will be the correct here. Okay, 4640 is the only correct answer. Okay, in this answer we didn't include the biases.
But they have asked including bias, na ma'am.
Yes, they have asked including bias, but there is no option is matching exactly with this. So if we include the biases, so that means each filter have each one bias at least. So 32 bias must be added here, right? So that's why no answer is matching. So no option is matching here. If they say that excluding bias, or if they did not define, if they didn't define this one, so the answer will be the 4608 in that case. Okay, so just see all these points, whether they are asking about biases or not. If they are asking and no answer is matching, so you can raise the I mean later, or you can just stick with excluding bias and then I mean mail them like this. And most of the cases in exam there is a no this type of problems will be happening. Okay, so now moving to our next question. In a standard deep convolution neural network, where is the batch normalization layer typically inserted? Option A, before the convolution or fully connected layer and after the activation function. Option B is after the convolution or fully connected layer and before the activation function. Option C, after the final output layer, that is the softmax. Or option D is directly after the input image but before the first convolution. Which option is correct? In a standard deep convolution neural network, where is the batch normalization layer typically inserted? So, would you like to answer this question? Please make a guess at least for this question. Then we will see the solution for this. Okay, option B, directly after the input image, but before the first convolution. Okay, okay, so let's see the detailed solution for this one. In the detailed solution, the standard and most effective placement of the batch normalization is after the convolution or fully connected layer and before the activation function. Okay. The purpose of batch normalization is to normalize the activations, specifically the input to the next layer's non-linearity of the previous layer. Okay. So in general, the sequence for the deep neural network is input layer, then linear transformation, that is convolution or fully connected layer, then batch normalization, then non-linearity, that means activation function, then output. So this is a general sequence for the any deep learning network. Okay, that is a standard deep learning. network. The original paper and empirical evidence suggests that normalizing the output of a linear transformation before applying the nonlinear activation helps the network learn more effectively by keeping the inputs to the nonlinearity in a more stable, non-saturating range and accelerating convergence. So the correct answer for this question, after the convolution or fully connected layer and before the activation function, the batch normalization has been used to normalize the activation. That activation, basically we are applying the non-linearity to the network. So before that we have to normalize our network or values. Okay, so for this, option B is the correct choice or correct answer for this question. In a standard deep convolution neural network, the batch normalization layer inserted after the convolution or fully connected layer and before the activation function. Okay, it is directly not applying in the input or before the first convolution. Okay, okay. So now moving to our next question. So the primary contribution of the residual network, that is resonant architecture, which allowed for the training of the extremely deep network, was the introduction of option A, inception modules to capture multi-scale features. Option B, depth-wise separable convolutions to reduce computation. Option C, auxiliary classifiers to supply gradient to lower layers. Or option D, identity shortcuts connection to bypass layer. Which option is the correct for this question? The primary contribution of the residual network, that is resonate architecture, which allowed for training the extremely deep network, was the introduction of. So would you try to answer for this question? Try to answer for this question. Okay, so let's see the solution for this one. So the solution is to identify shortcut connections or skip connection. So this is a definite defining feature of the resonate. So these connections create a residual block where the input X is added to the output of a stacked layer, that is Fx, and the resulting block's output, that is Hx, Fx plus Fx. Okay, so this structure compels the network to learn the residual mapping Fx, that is Hx minus X. This residual formulation is much easier for the network to optimize the learning, the identity mapping Hx, right, especially for the deeper layers, and that is a critical for shortcut provides a direct path of the gradient x and to flow back through the network effectively, solving the vanishing gradient problem that clogged very deep plane network. Okay, so already we have seen in one, I think first question, not a question 5, in the question 1, inception modules are the core of the Google Net. That is in the question 1, we have seen that. Okay, so depth-wise separable convolutions are the key features of for the mobile net, that is not for the ResNet, and auxiliary classifier that were used in the Google Net to fight vanishing gradient to providing image. So that is also not a correct answer. So a correct answer is the identity shortcut connections to bypass layers. Okay, so option D is the correct answer for this question. This is basically the primary contribution of the ResNet architecture is identity shortcut connections to bypass layers. Okay, which allowed for the training of extremely deep networks that has been introduced in the ResNet. So option D is the correct answer for this question. Okay, okay. So now our questions have been completed. So if you have any doubt, you can ask. Otherwise, we can close the session. So thank you, everyone. Thank you for joining this session. Now, if you have any doubt, you can ask.
Thank you so much, ma'am.
Yeah, thank you. Thank you, everyone. Thank you for
Thank you for
joining
your
this session.
patience. Good
Okay.
night, ma'am.
Good night. Good night.
She is your fam, man. Of course,
Okay.
your patience is very great, ma'am. Really, you are wonderful. I am also listening other three sessions also, but your
Okay.
patient writing, all those things are really appreciable and very much helpful to us. Thank you so
Oh,
much.
okay. Okay. Thank you. Thank you. Okay.
Okay, ma'am. Good night.
Good night. Good night.
Eh, Jarga.
So thank you, everyone. Thank you for joining this session. I will take one extra summary session on the Wednesday, that is 8th October. So I hope you will be the joining that session. Okay. So thank you, everyone. Thank you for joining this session.